Welcome to my lesson on percent applications. Okay, previous to this lesson, we had worked through an activity where we had found the part in a percent application. And I started out looking at this sentence here. 30 is 75% of 40. There's no calculating to do here. The only reason I put this sentence up here is I wanted to make you, or draw your attention to the different components in a percent application problem. The 30 is the part or the portion. Those are two words that we often use for that. The 75% is our percent or our rate, and the 40 is our whole or our total or our base. Last time I went over different ways that we could find these different components, and we started out working on finding the portion or the part. Today, in this lesson, I want to go ahead and take a look at using those same methods to find the percent or the rate, or finding the whole, which we also call the total or the base. The two methods that I showed you was the first one was the proportion method, where we looked at the ratio of the part over the whole is equal to our percent proportion. And so we looked at our cross products where we cross multiplied and divide. Wherever we had a diagonal of numbers, that's where we multiplied, and then we divided by the lone term. Now keep in mind, this only works if you have equals in here, because remember, when we have equivalent ratios, our cross products are equal to each other. If we have plus, minus, multiply, or divide in there, we need to use our fraction skills for addition, subtraction, multiplication, or division. The other method that I looked at was the equation method, where you're just looking at the equation part is equal to the percent decimal times the whole, and all we had to do was plug in and find our answer there. That was pretty straightforward when we were finding the part. In this lesson, we want to take a look at finding the percent and then later finding the whole. Now, another problem that I had given students in another video when we first started looking at converting fractions, decimals, and percents was a situation where you were taking a quiz. You had an 8-point quiz and you'd scored 7, and so the ultimate question there was, what's your percentage? In other words, 7 is what percent of 8? Okay, and again, we are finding the percent in this problem. Okay, I'm going to use these two methods, and then we're going to cut to the chase. The first method, using our proportion part over whole, 7 is our part that we had correct out of the total number 8, should be equal to some percent number over 100. And we could use this method and go ahead and take the cross product where we have a diagonal of numbers multiplying there. So after clearing, 7 times 100 and then divide by 8 would give us 87.5, and then we remove that from our percent ratio, we would just identify that as 87.5%. Now the second method, where you put part is equal to our percent written as a decimal times the whole, we know our part is 7, it's equal to some percent of 8. Well, this is where you get the opportunity to utilize some algebraic reasoning. In algebra, you've got an equation and you have a variable. In this case, I'm just using the percent symbol, and I'm trying to isolate or get that percent symbol by itself. I want to find out the connection to the number that I have there, which is 8. The connection there is multiplication. So I want to analyze, in isolating and getting percent by itself, I'm going to have to get rid of the 8. I identify the connection as being multiplication, so I need to ask myself what undoes multiplication, or what is the opposite of multiplication, and that would be division. If I divide this side of the equation by 8, that allows the 8's to reduce. Whatever I do to one side of the equation, I have to do to the other side of the equation. So this would justify where you take part divide by whole, and this is the route that we took when we first converted fractions to percents. So clearing this, we're going to say 7 divided by 8 is equal to, and we ended up having our percent is equal to this decimal, which is 0.875, and to convert that to a percent, we need to move the decimal 2 places to the right, and that would be 87.5%. Now, that was really kind of dragging it out, to be honest. In short, I think we all know from previous experience that we can just take part, divide by whole, gives us our percent, and we just need to convert that percent to a decimal. And that is exactly what we did when we converted the fraction 7/8 to a percent. We divided top number divided by bottom number, and then moved our decimal 2 places to the right. So cutting to the chase, this would probably be what most students would do. They would not bother to set it up in either of these, but I just want to show you both of those because they can justify your reasoning for part divide by whole equal to percent. Okay, the last thing that we need to do in this whole process is solving for the whole. I'm going to give you an example here where we're going to say that an equation here, or a problem. Now I want to say 32 is 25% of what number? So again, it isn't very clear, but 32 is 25% of what number? In this case, I'm looking for my whole here. And I can use, again, both of these methods. I'm going to start with the first method where I cross multiply and divide. So I need to set up my structure for that. And I need to put things where they belong. 32 is what percent? This is my part. The 25%, again, we can just put that in the percent ratio. So I've got everything where I need, and it's obvious that I need to find my whole here. So I'm going to cross multiply where I have a diagonal of numbers and divide by my lone number. So setting up my calculator again. I'm going to say 32 times 100 is equal to, and here I'm going to divide by 25. Gives me 128. So I found my whole to be 128. A lot of students like the cross multiply and divide method for any of these three, finding the part, the percent, or the whole, simply because once you get everything into the proper place in your proportion, the proportion tells you what to multiply and divide by. You don't have to memorize anything. So that's the smooth thing about using the proportion method. Just get everything where it needs to be, and the proportion tells you what to do. Okay, the other method, which I'm promoting here, is the formula method where you are, well, the equation method where you're plugging into this equation. Part is equal to our percent written as a decimal times the whole. So in this case, I have 32 is, so 32 is equal to 25% written as a decimal would be 0.25 times our whole. And I don't know what the whole is, so I'm just going to write n as a variable representing our unknown whole. Okay, again, this is another good opportunity for you to get some experience with algebra. You've got an equation here, and you need to look at the right side of the equation where my variable is and figure out what's the connection between 25 hundredths and n. The connection there, the operation, is multiplication. And again, in algebra, our goal is to isolate our variable. So we've got to get our variable n by itself. The connection to the 25 hundredths is multiplication, so we ask ourselves, how do we undo multiplication? And that would be division. So I can divide this side by 25 hundredths, which allows that to reduce. And again, whatever I do to one side of the equation, I have to do to the other side of the equation. So I end up, this is what justifies that you can go ahead and take 32, divide by 0.25. And again, you're going to get your n is equal to 128. And again, when I'm doing algebra, I need to bring everything straight down. In fact, I think I'm going to write the problem over again at the very beginning so that you can see that's what we started with, was 32 is equal to 25 hundredths times n. And so you can see what the process was in getting to our resolving and getting to our answer. Okay, so the right side allows you to use the equation method, which lends itself to developing some algebra skills. The left side of our paper here, we were using the proportion skills. Now, the sad thing is, you're not going to get these straightforward questions, you know, some number is some percentage of some other number. You're going to get these percent applications problems in a word problem. So you need to be able to read your problem and comprehend what is my whole, what is my part, what is my percent, what am I looking for, and understand these components so that you can plug in to either of these methods. And I can't really say that I feel one method is better than another. They're both equally important, as you will find that you're going to use both of these methods as you move forward in preparing for your GED. Thank you for joining me in this lesson.